All right, so jumping back into where we left off last time, I wanted to do some example problems of adding and subtracting fractions with different denominators just so that it's a little bit clearer, because I think we only had one example at the end of class last time. So I want us to add 2/5 plus 3/10 and see how we could approach this problem. Okay. So the first thing that we could do to approach this problem, or one of the ways, is by drawing a picture. Now, drawing a picture is sort of time consuming, so it's not something that you would want to do every time. We have some rules or some skills that we can apply to make this a little bit faster. But drawing a picture really helps really understand what's going on with adding fractions for smaller denominators. So drawing a picture is helpful for smaller denominators only. Once we have bigger denominators, we want to sort of not have to draw a picture. And what do I mean by that? Well, remember I said that the denominator of a fraction tells you that you have some object and it's cut up into that many pieces. So for this first fraction, we could think about having a rectangle that I'm going to chop up into 5 even pieces. So I know that this isn't a perfect rectangle, and I'm going to do my
Sir, I have a
best.
question.
Sure.
Last time when we went over this, I remember there was a bottom part that's the same part. Why is this time there's a different bottom equation?
The denominators are different, right? We're gonna have to make them different, the same, but we'll see that in a second. So just bear with me, okay?
Okay.
So first, this object here, we have 2/5. So you could think of that as like a bar of chocolate that's chopped up into 5 even pieces. So I'm going to cut this up into 1, 2, 3, 4. So that's 4 cuts, which has 1, 2, 3, 4, 5 pieces, right? And what we have is 2/5. So we really just have 2 of these sort of smaller rectangles. Okay, that is 2/5. That fraction is represented by this highlighted portion. Okay, and what we're trying to do is add that to another rectangle, but that rectangle, which is the same size, is broken up into 10 smaller pieces. So we could break this up into 5 pieces for sure. 1, 2, 3, 4. So we have 1, 2, 3, 4, 5 smaller rectangles to make up the larger one. But if we wanted 10 smaller pieces, let's cut those in half. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these smaller squares. In fact, these are 1/10 each of these little squares. And we have 3 of them. We have 3/10. So really we would have just 3 of these little squares here. Okay. And we're trying to add the highlighted portions together. But in the same way that if I went to a supermarket and said I had 2 apples and 3 oranges, if I tried to add them together, I couldn't say that 2 apples and 3 oranges is equal to 5 apples, because 3 of those things are oranges. They're not apples. I can't just combine them because they're not the same kind of object. Similarly, if I have 2/5, these rectangles are larger than the 3/10 here. So they're not the same kind of object. This is a sort of a rectangular shape, and this is more like a small square. So if I want to add them, I need to somehow come up with a way of representing them as the same thing. So one thing that you could do with a picture like this is say, well, if I, for some reason, went ahead and divided up this rectangle in half, like so, well then I can say that now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 smaller rectangles or smaller squares making up this chocolate bar or whatever the object is. So I've changed the denominator, the cut size, into tenths. And how many of those tenths do I have? I have 1, 2, 3, 4 tenths. Okay. Now that I have 4 tenths, I can add that to the 3/10 that I have over here. Okay. And so if I have 4/10 plus 3/10, as we saw last time when you're adding fractions that have the same denominator, we're going to keep that common denominator and we're going to add the numerator. So 4 plus 3 is 7. And that will be our final answer. Right? You might ask yourself, can I reduce this fraction? And it turns out that in this case, you cannot. Okay. Does anybody have any questions about this problem? Okay. Well, like I said, in most cases, you're not going to want to draw a picture of chocolate bars because if we have larger denominators, you're going to have to, let's say this denominator was 25 and this one was 100. You wouldn't want to take a rectangle or some circle and then cut it into 25 smaller pieces. It's just going to be very cumbersome. So instead, let me give you hopefully a trick so that we can go ahead and add some fractions together or subtract them and get that common denominator. So let's do 3/4 minus 1/12. Okay. Well, if we're going to add these fractions or subtract these fractions rather, we want to look at the denominators and make sure that they match because otherwise we cannot subtract. So we need to match our denominators. Okay. And if you look at the last problem, you might say, okay, well, we had a denominator of 5 to start off with. And somehow we took that 5 and it got transformed into a 10 by multiplying almost. So what do I need to multiply by 5 to make 10?
Two.
Yeah, I just need to multiply a 2. Well, it turns out that, the 2 on the numerator also changed into a 4. So it's like I multiplied by 2 on the top as well. So that means that what I essentially did was multiply by 2 on top of my fraction and 2 on the bottom of the fraction so that I can change that into 4/10 and match the denominators. So if I can look at my two denominators, make a comparison, and you might, try this strategy. 12 is a larger number. Can I multiply a number by 4 to make it turn into a 12?
3.
Yeah, 4 times 3.
4 times 3, right? So 3 is the number that I need to use here. And just like on this last problem, if I multiply that number on the bottom, I also have to multiply that number on the top. So we'll go ahead and multiply this fraction by 3/3 so that we can change it to 9/12. Right? 3 times 3 is 9. 3 times 4 is 12. And now, if I just bring this fraction down, we didn't have to do anything to it. They have the same denominator, right? We have matched these. Okay. Okay, well, if those match, that means that we can go ahead and do the subtraction problem, and we can call this now 9 minus 1 is 8/12. And if we needed to, we could reduce this fraction, right? Can anybody tell me what this fraction reduces to?
2/3.
2/3, yeah. And how did you get that?
The least common factor is 4.
Okay, I see. So you're saying that you took 4 and you divided it out from the top and bottom, right?
Yes.
Okay, yeah, that's definitely one strategy. So 8 divided by 4 is 2. 12 divided by 4 is 3. And that'll work. Okay. Now you might be wondering, why is it that I can multiply this number by 3/3 and it not affect the problem? Has anybody ever wondered that? So I'm going to make a note over here. Can somebody tell me if I have a number divided by itself, what should the result be? Think of any example number, like 10 divided by 10.
0.
10 divided by 10 is 0. Let's go ahead and throw that in the calculator.
1.
It's 1. Right? Like if I had 10 friends and 10 cookies, and I wanted to divide my 10 cookies among my 10 friends, how many cookies would each of them get? 1. Right? So any number divided by itself is just 1. So if I multiply this fraction by 3/3, that's the same thing as multiplying by 1. So it's not going to change the value of the fraction. It's only temporarily going to change what the fraction looks like, right? And we needed those fractions to have the same denominator. So if we multiply by a convenient form of 1, that's going to be the trick that helps us find that common denominator. Okay. Does anybody have any questions or comments about that? We're going to look at some more examples here in a second.
I'm still copying the equation number 2 or the problem of number 2.
This one?
Yeah, because I just barely finished the problem number 1.
Okay. Is anybody else still writing?
You know what? I don't want to take up the whole class time. I just catch it on whenever you upload today's notes.
Okay. All right. Just try your best to listen, and if you have any questions as you're following along, feel free to ask those. Okay. Let's go ahead and look at another problem, number 3. If I had 3/7 plus 2/3, we want to add these fractions, but this one isn't as nice as the last one. In the last fraction, we had denominators of 12 and 4. And the 4 can be multiplied by something to give us the 12. But we need a common denominator between 7 and 3. We need to match these. So we need to match. But, I can't multiply 3 by a number to give me the 7. Right? If I multiply 3 times 2, that would be 6. 3 times 3 would be 9, and I've overshot the 7. So can anybody tell me what is the strategy for finding that common denominator?
Hey, sir.
Yes.
Does that say 2/3?
Yeah, 2/3.
Okay, I couldn't see because my eyes were going blur for a minute.
Okay, 2/3. Anybody have any strategies for finding the common denominator here, or does anybody know what the common denominator will be?
21.
Yeah, how did you find that?
Finding the LCM.
Yeah, okay. So last time we learned that we could list the multiples, right, of 7 and 3. And then whatever the lowest common multiple or the least common multiple, that is the smallest number they have in common, that's what we're going to go with. So we can count by 7s, 7, 14, 21, 28, 35, 42, and so on. We can count by 3s, 3, 6, 9, 12, 15, 18, 21. And we can actually stop there because now we have a number in our lists that is the same. That is, we have 21 here, and 21 here. That's the first number that appears that is common between these two lists of multiples. So that gives us a strategy for how we need to transform these fractions. We need to make these fractions so that we have 21 as our common denominator. So the least common multiple, or the least common denominator, will be 21. But how can I change this 7 and make it turn into a 21? What do I need to do?
Is it divide?
Well, I want to get 7. I want to get the 7 and change it somehow, do something so that it grows to a bigger number and becomes 21. Right? So what could I multiply by 7 to make it turn into 21?
3 times 7.
Yeah, I would take 7 times 3. So this is going to give me a clue as to what I need to do to this fraction to transform it. And that is, I need to multiply this fraction by a convenient form of 1, which is going to be 3 over 3. Okay. So 3 times 7 will give me the 21 on the bottom. 3 times 3 is going to give me a 9 on top. So it turns out that 3/7 is equivalent to 9 over 21. Okay. 2/3. I want to change this 3 and multiply it by something to get 21. What do I need to multiply? Well, if you go into your list gives you a clue. This is 3 times 1 times 2 times 3, 4, 5, 6, 7. So I need to multiply this by 7. Which means that this fraction needs to be multiplied by 7 over 7. Okay, so 3 times 7 will be the 21 on the bottom. And since we have to multiply the same thing on top, 2 times 7 will be the 14. Does anybody have any questions about that? Okay. Well, now that we have a common denominator, like last time we saw when we're adding fractions that have the same denominator, we can just add their numerators. We have these objects, the 21sts, right? 9 21sts and 14 21sts. So 9 plus 14 will be 23. So we'll have 23 over 21 since we keep that common denominator. And since this fraction cannot be simplified, doesn't have any common factors on the top or bottom that we can cancel out, then that must be the final answer. Okay. Now, one note that we might make is that this is what's called an improper fraction. Okay, in grade school or in your previous math classes, wherever they may have been, you may have been taught that we don't like improper fractions. And that is simply not true in higher education. So at college and beyond, we don't care whether these are improper fractions or mixed numbers. We'll talk about mixed numbers a little bit next week. But an improper fraction, the definition is that it's a fraction whose numerator, that is the number on top, is larger than the denominator, or the number on bottom. And so you could think that these are improper in the sense that the fractions are top heavy, or like a upside down pyramid, it's sort of unbalanced, right? It can lose its balance easily. Now that's just an intuition for like why we call them improper fractions. They are perfectly fine. And as long as that fraction, improper or proper, is fully reduced, that is an acceptable answer, okay, until we start working with mixed numbers. So for now, since this fraction is fully simplified, we're going to say that this is the final answer, 23 over 21. Okay, does anybody have any questions about adding and subtracting fractions with different denominators?
You don't have to turn the fraction.
So that would be the,
So we don't have to turn the fraction into what?
into a decimal.
No, in fact, you will not turn the fraction into a decimal unless the question specifically asks for a decimal answer. For our purposes, you know, there are some problems in Hawks where if you try to type a decimal, it'll say that that symbol is not needed for this problem. So for our purposes, we're going to leave our answers as fractions. Okay, what was the other question?
and then that also goes for like when the question says to reduce it, we reduce it unless it says to reduce or change into, how do you, I don't know, not the improper fraction, but how you do that, it would be 1 with 1/21, right? We wouldn't change it into a mixed number unless it says to reduce
Right, so that's what I
mixed
was
number,
saying.
then
Like,
we would do mixed number.
so it, unless it specifically asks for a mixed number, which it shouldn't, then you will leave it alone, leave it as a fraction. Okay, whether it's improper or not, we're going to accept improper fractions as perfectly okay. But it does have to be fully reduced. So if this can be reduced, then you will do it. But if not, then you can't do anything. So we'll leave it alone. Okay, we're not going to worry about mixed numbers until we get to that probably next week. Okay, good questions, good discussion. All right, so make sure that if you are struggling with adding and subtracting fractions, that you seek help with the tutors in Math World. Remember that that is a live service, and you know, while you are working remotely at home, you know, due to weather or whatever, that they are waiting by the computers, waiting for you to go in and pop in and ask for help on your homework problem. So if you're getting stuck on Saturday or Friday, then make sure you visit with them. And if you're, you know, still having trouble, make sure you're sending me messages or screenshots of the problems that you're working on so that I can give you some notes as to how you should approach the problem. Okay. All right, so that's going to conclude the addition and subtraction of fractions for us. Today, we're going to focus on multiplying and dividing fractions, and we're going to be able to tackle both of those operations because multiplying fractions and dividing them actually a lot easier than adding and subtracting fractions. So this is going to start us off in section 2.2. I know I'm a little bit out of order. Don't mind that. I think that this is a more natural order for us. Multiplying fractions. Okay. And like I said, you know, when we're dealing with whole numbers, we tend to think of multiplication and division as being more complicated procedures compared to addition and subtraction. Well, it's sort of the reverse case when we're talking about fractions. Multiplying fractions, dividing fractions, actually easier than adding and subtracting. So I'm going to give you the rule for multiplying fractions. So this will apply in all cases when you're multiplying two fractions together. And we'll see how straightforward this actually will be. Okay. So if I have A over B, some fraction with a number on top, number on bottom, how we expect fractions to be, and I multiply that by another fraction, let's call that C over D, two different numbers, right? Then what my result should be is some fraction where on top I have multiplied A times the C, and on the bottom I've multiplied B times the D. Okay. In other words, you're multiplying straight across. You're multiplying the numerator times the numerator, the denominator times the denominator. Okay. And note, we do not need common denominators for multiplication or division.
Multiply versus A over B.
Yeah.
you said yeah for a multiply?
This symbol?
The little dot symbol.
Yeah, the dot means multiply.
Okay.
Okay. So let's look at an example. We'll sort of talk our way through this example and then we'll look at some more practice. If I was doing 1/3 and I multiplied that by 1/2. Using the guideline up here, the rule up here, what should my result be? Yeah, I think I heard that correctly. You're going to multiply the ones on top. 1 times 1 is 1. 3 times 2 on the bottom is 6. So our answer should be 1/6. And that fraction is fully simplified, so we're done. That's the final answer. Anybody have any questions about that one? Does that seem pretty straightforward? I think it's a lot easier than adding and subtracting fractions. Okay. Again, we didn't have to match denominators when we're multiplying and dividing. So if you are rushing into the problem and it's a multiplication problem and you're trying to get a common denominator, then you're doing too much. You need to slow it down and say, what world am I in? I'm in the world of multiplying. And in that world, we do not need common denominators. Okay. But I will say, you could think about this verbally, linguistically. If we were to talk about multiplying 1/3 times 1/2, you could think of that as like, take 1/3 of 1/2 of a pizza. And ask yourself, how big is this slice? Right? So if we did that, the word of here is implying that we're multiplying. And if we're taking 1/3 of 1/2, you can interpret that as, let's draw a pizza here. And we just have 1/2 of the pizza, right? So we really just have this half over here. Okay. That highlighted orange portion. That's our half. And if we wanted to take 1/3 of this, we would cut it up or divide it up into thirds. So imagine that I cut this up into thirds, like so. But imagine that I extended these lines straight across the entire pizza. Okay. Well, if I did that, and I chopped up the pizza again into thirds, or the halves into thirds, then what is the size of one of these slices? What is the size of this slice here? Well, remember, a fraction, the denominator tells you what is the size of the slice. So if we think about the entire pizza, we have 1, 2, 3, 4, 5, 6 of these.
Is that a half of a circle you just drew? Or
Yeah,
you made a line?
Half of a circle here.
Okay, because it looks like you drew, it looks like an X.
It's a half of a circle, but then I cut the halves into thirds.
Okay.
Okay. But then this slice, now that I've cut that into thirds, is worth 1/6 of the entire pizza. Okay. So in some sense, multiplying by a fraction, where we multiplied 1/2 times 1/3, is like dividing. And I will just leave that there. And we'll think about that a little bit later on when we get to division. Okay. But for now, that's one way that you could physically interpret how we multiply fractions. If I have 1/3 times 1/2, you could think of half of some object and then divide that into thirds. And the size that you get at the end, that's going to be your result. Okay. That being said, another thing that you need to be aware of is that all the sign rules, that is with positives and negatives, for multiplying and dividing, are the same. That means that a negative times a negative is a positive times a positive is a positive. If the signs are the same and you're multiplying, you get a positive. If the signs are different and you're multiplying, you get a negative. So there's no changes to our sign rules. So we just have to be aware if we have a positive and a negative fraction, what do we do with them? Okay. So let's do some practice. If I have -6/7 times 8/5, what should the result here be? How do I multiply these fractions?
-48/35.
There we go. -48/35. Perfect. Does that fraction reduce? Does anybody know?
I think it can by 7.
Does it reduce by 7?
Or can it be reduced like by 7?
If it can be reduced by 7, that means that there is some number, well, 7 divides into 48 and also into 35, right? But if we do that, let's just grab our calculator. 48 divided by 7 doesn't give you a whole number. So 7 won't work there because it needs to divide into both of these. It turns out that this is a simplified fraction. We can't do anything else with it. So this is the final answer. So one strategy that you can employ to try to see if you can reduce it is ask yourself, is there a number, let's say a smaller whole number, that divides into 48 and 35 evenly? And if there's not, well, if there is, then we'll divide that out from the numerator and the denominator. But if there's not, then we're done. Okay, so this is fully simplified. Okay, does anybody have any additional questions or comments about that problem? Okay, let's do 4/13 times 3. Can anybody tell me how I need to handle this multiplication problem? What's the first thing I need to do?
3/1 to make it a fraction.
Yeah, we need to take the whole number and write it as a fraction, so 3/1. So we'll have 4/13 times 3/1, and then we can get down to business. Okay. So that might be a note that's important here. Note that if I have a whole number, let's say
One
it's
quick
A,
question.
just one second. If I have a whole number that's A and I have A over 1, that's the same thing because any number divided by 1 is going to be itself. So in this case, 3 is equal to 3 over 1. So we can make that substitution. What was your question, Brianna?
Simplify, is it spelled S-I-M-P-L-E-F-I-E-D?
This is I-F-I-E-D.
F-I-E-D?
Yeah,
Okay, thank you.
you got it. So once we have gone ahead and processed our whole number, it is now a fraction, we can go ahead and just multiply straight across here. So 4 times 3 is 12, 13 times 1 is 13. And again, this is a fraction that is fully simplified as it is. So we should be done there. Does anybody have any questions about that one? Okay. If I have negative 4/3 times 5/3 times negative 2 over 7, what should the result there be? Any ideas?
What was the question?
If I have negative 4/3 times 5/3 times negative 2 over 7, what should the result be?
I got 24 over 63 positive.
How'd you get 24?
I did 4 times 2. Oh, I did 4 times 2, which is 8, and it turned into a positive because negative and negative, and then I
Yeah.
did the times 5. Oh, I multiplied wrong.
Yeah. Good catch though. Right. So we need to multiply all the numbers on top. So it doesn't matter what order in which you multiply them, since multiplication, the order doesn't matter. If you wanted to, you could just multiply the first 2 fractions first. Negative 4 times 5 should be negative 20. 3 times 3 is 9. So we'd have negative 20 over 9. Then we can just bring down the remaining fraction that we have to multiply. So multiply that by negative 2 over 7. And then absolutely right, that a negative times a negative is positive. So we should be getting a positive here. And I'm just putting the plus to make it clear that that rule is in effect. Negative times a negative gives us a positive. But then we just multiply straight across yet again. 20 times 2 is 40. And 9 times 7 is 63. So our answer should be positive 4 over 63. And again, you don't have to put the plus sign. Again, we have another case here where if you tried to reduce 40 over 63, it's not going to reduce. It's fully reduced as it is. So you always want to check if your answers can be reduced. Okay. Does anybody have any questions about that last problem?
What is the difference how it says negative 4 over 3, and then in the parentheses it says negative 2 over 4? How do we handle it? Is there like
2 over 7.
Oh, I'm sorry.
No, you're okay. Good question. There is no difference here, and I might make a note that when you read it to yourself, right, you said negative 4 over 3, right? So we
Yes.
treated that negative, and it's clear that the negative is on top of the fraction here, but we set it as -4/3. If I have the negative sign in front of the fraction, you still read it the same way, right? -2/7. So if that negative sign is in front of the fraction, it's the same as if it's on top.
Okay.
Yeah, it's the same way that you read it, -2/7. Okay. Some students do get confused, and in my last class they asked, if the negative's in front, does that apply to the top and the bottom? And no, it's just one negative sign. So it's -2/7. Does that answer your question? Does that clarify it a little bit?
Yes, thank you.
Okay. Now I will tell you that, maybe as a note here, that Hawks is okay with you putting the negative sign on top of a fraction. So let's say that I had -a/b.
You know what's also bothering me? Every time when I had to do something and solve the problem,
Okay.
some odd reason I keep putting the problem wrong because I can't remember how to put the fraction in to any type of problem that the
Okay.
answer may need.
Yeah, that is just like a technical issue. So usually, and let me go ahead and finish this point that I'm making about this negative sign. So first off, if you're putting a negative fraction into Hawks, you can put the negative sign on top of the fraction. That's going to be okay. Or you can put the negative sign in front of the entire fraction. That means the same thing. But what Hawks doesn't accept is when you put the negative sign in the bottom of the fraction. Okay. Now that is just a programming issue. The people that designed Hawks just made it so that it does not accept that negative sign in the bottom of the fraction. But any mathematician would say that these three things are the same. So for our purposes, just so that you don't run into that frustration, avoid negative signs in the bottom of a fraction. You can put it on the top, you can put it in front, but not on the bottom. Okay. Now, to Brianna's point, if you're having trouble locating the button to create a fraction in Hawks, when you're working on the problem in practice or in Certify, there should be a button that says keyboard. And when you click on that, you should
It's
be able
not
to
letting
see-
me use it.
Well, you should be able to see a symbol that has a fraction, like something on top and something on bottom. But if that doesn't work, use the backslash button on your keyboard.
The backslash. Okay.
Yeah, the backslash. I think it's the one that's with the question mark. At least on my keyboard it is. But if you use that backslash button, it should be able to toggle between a whole number answer and a fraction answer. Okay. Does anybody have any additional questions about multiplication? Okay. As far as multiplication goes, I think, again, that is pretty straightforward. And we'll see some more multiplication problems here when we get to division. But let's go ahead and move into division, and we'll see, what is the rule that we use for dividing fractions specifically. Okay. So dividing fractions is all in the next section, which would be section 2.3. So this is division with fractions. Okay. And so the first thing that I want to do to sort of prime our brains and get us ready to think about division, let's think about the following problem. 3 times some number is equal to 1. Can anybody tell me what that number is? Three times a number is equal to 1. What number can I multiply by 3 to get 1? Any ideas?
I have no clue.
Yeah. Yeah, it's sort of hard to think about, right? Like, can you tell me what your thought process is in trying to say like, okay, or, we're having trouble trying to find this number. But what are you thinking through when you're thinking about what this number should be?
I thought of 3 times 0, but then it would be 0, and then 3 times 1, but that would be 1. And then I thought of 3 times 0.5, but then that wouldn't be 1. And yeah.
Yeah. No, that's good. That's a good thought process, right? So like you went through 3 times 0, and that can't be right because that's going to be 0. 3 times 1 obviously has to be 3, so that's not going to work. And then you said, okay, let me try some decimal numbers, which is on the right track actually, but 3 times 0.5 is actually 1.5. So that's actually getting us closer to the answer here. But it turns out that, in my last class, I had a student say, well, maybe it's 3 times -1. But that's not right because that gives you -3, right? So we can sort of survey larger whole numbers like 1, 2, 3, 4, 5 and see, multiply that by 3 to see if we get 1. But we typically think that multiplication will grow our number. So if we have 3 times some positive whole number, we're going to get too big. It's not going to be 1. And the same thing is going to be in effect for our negative numbers. 3 times a larger negative number will be more and more debt, right? Or more a larger or a smaller negative number technically. It turns out that what students don't like to think about are fractions. And it turns out that 1/3 is the fraction that we need to multiply by 3 so that we can get 1. Okay. Now the reason why this is because let's multiply these fractions, right? We just learned the multiplying rules. What do I need to do with the whole number when I multiply this? I need to take 3 and write it as 3/1, right? And then I need to multiply that by 1/3. And when I multiply these fractions out, what do I get? Well, I multiply the numerators to get 3. Multiply the denominators to get 3. So I get 3/3. But what does this simplify to?
1. But where did you get the 1/3?
Oh, that's what I was trying to guess, right? Like I was trying to figure out what is the number that works here to multiply by 3 to get 1/3, right? That was the game we were playing. So we needed to figure that out. And I already knew what the answer to the question was, but I wanted to see if we could think through it, right?
Okay.
So we'll talk about this here in a second, but I just wanted to demonstrate that 3.
So what, 1/3 is not the answer to equal 1?
No, it is, because check it out, right? 3/3 simplifies to, you could think of it like division. 3 divided by 3 is 1. So that's actually the answer. We needed this guy, 1/3, in order to make that multiplication work. Okay. So I need to introduce a concept before we can divide fractions, and that is reciprocals. Okay. So a reciprocal of a number can be stated as follows. Every whole number, I should say every integer, because negatives have reciprocals as well. Every whole number except for 0 has a reciprocal, and a number times its reciprocal is 1. Okay. Well, how do you find a reciprocal? Well, if I have the number a, and let's just say that that's a placeholder for some number. To find its reciprocal, you would just put 1 over that number. So if I had 3, its reciprocal is 1 over 3. So if you already knew that multiplying a number by its reciprocal gives you 1, then that's how we can identify what number should have gone in the box here, right? I'm multiplying 3 times something gives me 1. It has to be the reciprocal of 3, which is 1 over 3. Okay, but if we have a fraction, let's say we have a fraction like a over b, then its reciprocal is going to be the flip of that fraction. We're just going to flip the denominator and numerator, call that b over a. So if we have a fraction, then this is its reciprocal. Okay. You guys still working on this page? Okay. So I want to give you guys some examples or some practice identifying a reciprocal. If I have one, let's say our first reciprocal that we want to find is 2/3. What is the reciprocal of 2 over 3?
Three over 2.
Yeah, 3 over 2. And if you're not sure, you can always check by multiplying those out, because anything times its reciprocal is 1. So if we did 2/3 times 3 over 2, okay, and we're multiplying those fractions, so we multiply straight across. 2 times 3 is 6, 3 times 2 is 6, and 6 divided by 6 is 1. So that checks out. Are you guys okay with that one? Okay, if I asked you to find the reciprocal of -1 over 5, what would the reciprocal be? Any ideas?
5 over 1, but I'm not too sure if it would be negative or positive because you said it's the opposite.
Well, I said that you flip it, right? So that's all we have to do when we find the reciprocal. So if we just flip this, we would have 5 over -1, right? But can we simplify this fraction, right? Can we think of this as a division problem instead? If I had 5 over -1, that's the same thing as 5 divided by -1. Does that simplify to something? Well, it should simplify to -5. Okay, so we can check that, if -5 is the correct reciprocal for this number, then we should be able to multiply them to see what we get, right? We should be getting 1, since a number times its reciprocal is just 1. Let me go ahead and put this in parentheses since that's a little bit confusing. Okay, so if I wanted to multiply these, I need to change my -5 into a fraction. So I could call this -1 over 5, that's the first fraction, times, and then change this guy into -5 over 1. Well, now if I multiply, I get a negative times a negative, which is a +5, and a 5 times 1, which is another +5, and 5 over 5 is just 1. So that checked out as well. Does anybody have any questions about that one? Okay. What is the reciprocal of 6?
One six.
Yeah, 1/6. And again, you could check it by multiplying 6 times 1/6, which is the same thing as 6/1 times 1/6. You get 6/6, which is just 1. So that checks out. Okay. Okay. So the reason why we're doing this is because we're going to have to use the reciprocal or this concept over and over again when we divide fractions. Okay. So if we are dividing fractions, the rule is pretty straightforward. It's a little bit of well, there's one more step than in multiplying fractions, but we'll see. Let me give you the rule for dividing fractions, and then we'll jump into some examples. So this is what we need to do when we're dividing fractions. Okay, if I have a fraction a over b and I'm dividing that by the fraction c over d, then what I need to do is rewrite this. And you might remember, you might recall that when I was talking about, let's see. When I was talking about dividing or multiplying fractions, which I can't seem to find that page. Is it here? Well, when I was talking about multiplying fractions, I mentioned that it's a lot like dividing something up. So we know we had an example early on where it was 1/3, this is a 3, times 1/2. And we took a half of a pizza and then we divided that up into thirds. So I said, okay, let's cut this pizza, this half slice into thirds, but we'll extend those cuts all the way through. And that's how we got our answer of 1/6. So somehow, when we multiply fractions, that's related to taking an object and actually dividing it up into some number of pieces. So multiplication with fractions involves division. And this might seem strange, but for a mathematician, it turns out that multiplication and division are actually the same operation. We don't regard them as something different. So when we divide fractions, a mathematician would say, well, it'd just be easier if we could just multiply. So the rule that will work in all cases is that we won't actually technically divide these. We're just going to take our first fraction, a over b. We're then going to switch to multiplication. And then we're going to flip the second fraction to its reciprocal, which would be d over c. Okay. And multiplying by a reciprocal turns out is the same thing as dividing. Okay. So if we're back in the world of multiplication, then, well, then the rules for multiplying fractions apply, and we can just say A times D is going to be our new numerator, and B times C will be our new denominator. Okay, so this is the helpful phrase that I'm going to give to you that you will repeat to yourself over and over again. When you're dividing fractions, you want to keep the first fraction you want to switch to multiplying, and then you want to flip the second fraction to its reciprocal. So you will keep, switch, flip. Okay. And it turns out that, this rule, keep, switch, flip, is not only applicable to fractions. It's also applicable to whole numbers. We just don't typically learn division with whole numbers this way. So just as an example, and it might be more complicated than it needs to be, but just go with me. If I had 4 divided by 4, and I apply the keep, switch, flip formula, that means I should keep the first fraction or the first number, switch to multiplication, and then flip the second number to its reciprocal. So 4 divided by 4, it turns out is the same thing as 4 times 1/4, since that's the reciprocal of the second number. If I needed to multiply these fractions, then what I could then say is 4 is the same thing as 4 over 1. I'll multiply that by the reciprocal here, which is 1/4, and I'll get 4 over 4, which turns out to be 1. Okay, but that's the same thing as saying 4 divided by 4 is equal to 1, right? So it turns out that division is the same thing as multiplying by a reciprocal. Okay, again, it seems like a convoluted thing to do with whole numbers. And in fact, you would just say, I've memorized my times table, 4 divided by 4 is 1. Perfectly acceptable. But with fractions, you will have to do the keep, switch, flip, because that's really the only way to process these things. Okay. So, does anybody have any questions, comments, or concerns about this rule for dividing fractions? Okay, then let's do some example problems. Let's get some practice in. Practice. We have 3 divided by 4, sorry, 3 over 4 divided by 2/3. Okay. So I'll give you guys some time to catch up emotionally, spiritually, physically. Okay. So what you don't want to do is don't make the mistake of trying to divide any of these numbers like you would with whole numbers. Don't try to say 3 divided by 2 and 4 divided by 3, because then you're rushing in and you're going to make a lot of mistakes, right? You want to apply the rule that I just gave you. Every time you see a division problem with fractions, keep, switch, flip. So what we should do then is change our problem. We'll go ahead and keep the first fraction, 3/4. We'll switch to multiplication, and then we will flip this second number to its reciprocal, which would be 3 over 2. Okay, then we can just we're back in the world of multiplication, so we can just process that multiplication out. So 3 times 3 is going to be 9, and 4 times 2 is going to be 8. This fraction does not reduce, so that's going to be our final answer. Does anybody have any questions about that problem? So once we keep, switch, flip, we're back in the world of multiplication, and that should be more straightforward. Okay. So I'm going to go ahead and write -4/9 divided by 3/5. And we will work through this one together. Okay. Well, we're going to go ahead and apply keep, switch, flip. So I'm going to keep the first fraction, -4/9. We're going to switch to the world of multiplication and then flip this to its reciprocal, 5/3. Then we can just multiply straight across, since that's how we multiply fractions. So multiply that and that, this and that. And we should be getting -20/27. And that is our final answer there, since that fraction cannot be reduced either. Any questions about that problem? Okay. If I have 3/4 divided by the whole number 4. Does anybody know what the first step we have to take to process this problem? Anybody at all?
So you keep, switch, flip 3/4, and then you're going to change the division to multiplication. Oh, the receptacle. You have
Yeah,
to put the 4/1. I'm sorry, I know how to do it. It's just everything's just everywhere right now.
yeah. You said you have to take this as 4/1, right? And then we flip
Yes,
that.
but yes, 1/4.
Boom, perfect. And then once you're in the world of multiplication, we'll just multiply straight across. So this should be 3/16. And again, that fraction doesn't reduce, so we're good there. Okay, 16/27 divided by 8/9. Well, we can just jump in and continue. We're just dividing fractions, right? So you have to be mindful of what operation we're doing, and that will tell you what rules you are doing. Notice that with multiplying and dividing fractions, we don't care about common denominators at all. You only care about common denominators with adding and subtracting. Okay, so if we're in division, not worried about common denominators. We're just going to strictly apply keep, switch, flip. So we'll keep 16/27. We'll switch to multiplication, and we'll flip 8/9 to its reciprocal, which is 9/8. Okay, then we have to multiply that out, right? That's one way we could do this. And if we multiply this out, 16 times 9 should be 144/216. That's the 27 times 8. But that fraction can be reduced. And unfortunately, it's a really big fraction. So can anybody give me an idea of what is a pretty big number that divides both into 144 and into 216? Any ideas? mean, it could be a relatively small number, but we're just looking for some number that divides into both 144 and 216 evenly.
Be 12.
Yeah, 12 will work. So let's see what happens if I just divide that by 12, divide this by 12. Okay, so I'm going to go over here. And maybe I'm going to grab my calculator for this. Just in the interest of time, 144 divided by 12 is 12. So boom. And then 216 divided by 12 is 18. Can this fraction be reduced further? Is there a number that divides into 12 and 18 evenly? Well, I know that 2 will work and 3 will work, but there's a larger number still that will work, and it is 6. So I'm going to divide by 6 on the top and the bottom, and that will give me 2 over 3. And now that fraction is fully simplified. Okay. So at the end of every fraction problem, whether it's addition, subtraction, multiplication, or division, you just need to make sure that your final result is fully reduced or fully simplified, that you've divided out any common factors. Okay, but that will take some practice. Luckily, there are homework assignments involving fractions now that have been posted to Hawks that will give you an opportunity to practice these skills. Okay, so make sure that you get in there over the weekend and that you work on those things. I will post these lecture notes and the video to Canvas here within the next hour or so. So I will send out an announcement saying that that has been uploaded and just giving you a reminder of what is due by Sunday. Okay, so that's all the time we have for today. I will see you guys next week. If you have questions, you can message me or hang back to chat, but otherwise, enjoy your very cold and very wet day.
Have a good day, sir.
You too.
One more thing.
Yeah.
Did you get the email? Because you're supposed to get an email today.
I was in class before or after we talked earlier this morning, so I'll have to check here in a second. I'll
Okay.
let you know. I'll send you a message if I got it.
Okay.
Okay.
Thank you.
Yeah, you got it.
All right.
Hey, Jason, are you still there? I know you were having issues with your computer, with your internet.